Now look at GM tube again. GM tube is an apparatus used to intercept, used to identify, or used to detect ionizing radiations. Please update this definition. GM tube is an apparatus used to detect and identify ionizing radiations. GM tube, this is the outlook of a GM tube, and it has a rate meter. When GM tube is working, it will capture, and it somehow, if an alpha or beta particle enters, it shows the count rate. It shows the count rate on the apparatus screen. Now, the count rate shown is measured in counts per minute, which can be also in counts per second. This is how we set the apparatus. We will always set put the radioactive source in a lead lined box, and we should keep the radioactive source close so that GM tube can detect alpha particles. Alpha particles actually cannot travel much. This is the problem. Alpha particles cannot travel much, so you need to put it very close. Now, GM tube displayed count rate. The output of a GM tube can be a count rate display, and it is actually having a speaker also. It is having a speaker also. So now you have to copy this.
The normal background radiation sounds like this. But this rock is a little more interesting. And it's this rock which turned out.
So you have noticed the sound. GM tube can also produce a sound. Now we move to our next concept for today. There are different radioactive sources in our knowledge. There are different radioactive sources. Some are alpha source, which emit alpha particles. Some are beta sources, which are emitting beta particles. There are some sources which are alpha and beta combined. Okay, now you have to copy this screen.
Done.
Now, some are alpha sources, some are beta sources. Gamma rays are not properly detected by our GM tube. This is our next concept for today. GM tube is very effective for alpha particles, beta particle, but why gamma rays are not normally detected? Because gamma rays are not much ionizing. GM tube actually works on the principle of ionization. So gamma rays are never perfectly detected because gamma rays are not that much ionizing. So you have to copy this screen.
Done.
Now, our next concept, the count rate of a GM tube fluctuates. It moves up and down. It is like a stock market. It is like the temperature of a chemical reaction. Count rate fluctuates. So now write under it, the count rate of a GM tube, the count rate of a GM tube fluctuates. The count rate of a GM tube fluctuates. The count rate of a GM tube fluctuates. So it is random in nature. So it is random in nature. Random means fluctuating. Look at this screen. For example, it becomes 200. Then it suddenly becomes 210. So it is like a stock market. It is like a index number which keeps on changing because radioactivity is not a permanent phenomena. It is a fluctuating phenomena. You have to copy this.
Done.
Now, applications of a GM tube. GM tube is used for safety purposes. It is used for analysis, and it is also used for the purpose of research in a laboratory or in any installation. So you have to copy the list of applications.
Done.
For example, you put a radioactive source in front of it. You put a radioactive source in front of it, and this is a GM tube. Now I put a sheet of paper. If I put a sheet of paper and the count rate drops, it means it is an alpha source. I hope you remember alpha particles can be stopped by a piece of paper. If I
Yes.
place an aluminum sheet and the count rate drops, it means it
And
is
it's
a
the beta.
yes. A GM tube can be used to detect leakage in underground pipes, which is a very big problem. If you have come across anytime this, if there is a leakage, if there is a leakage under the ground, these pipes are very fragile or with the passage of time. So you can enter a radioactive source. And where there is a leakage, the radioactive source came out and will stop in the ground. So this will be a feature. This will be a feature which GM tube can help you to detect. Instead of rupturing the whole floor, you can use GM tube to precisely locate where is the leakage. Now give a new heading, background radiations. What is background radiations? Radiations is all around us. Radiation is all around us. So what is background radiation? It is the radiations which are already present in our environment, and they can produce a count rate. They can produce a count rate on GM cube. So give a heading background radiation, then give a side heading introduction, and write under it radiation is all around us. Now then write under it that it is the radiations which are already present in an environment and they are detectable and they are detectable on a GM cube. So these are the radiations which are already present. They are not radioactive rays. So they are called background radiations. For example, now look at this diagram, and there is no source. There is no source. Now the count rate will be background count. Why now the count rate will be background? Because there is no radioactive source. So count rate will be coming from the environment. So this is a GM cube. Look at the screen, and you have placed a radioactive source. This is a GM cube, and you have placed a radioactive source, and you are getting 100. This is the total count. Now there is no source. Still count rate is coming. This is the background count. So in order to adjust it, you have to subtract it. Background count means no radioactive source. Environment is generating some radiation, and radiations are always present. Now you have to copy this screen. Background count is a concept of count rate coming from the environmental radiations.
Done.
Good. Now, look at this concept. Background count is also random in nature. Random means fluctuating. Random means fluctuating. You have to copy this.
Done.
Background count is also fluctuating. Now, we are discussing in our course what are the sources of background radiations, from where they are coming up. So these are there is a gas in chemistry, we find it in noble gases, radon, it's a radioactive gas. Rocks and buildings, food and drink, cosmic rays from the food and drinks, cosmic rays from the sun. Cosmic rays are actually coming from the universe and they are universal rays. So there are different sources in our there are different sources in our knowledge which are creating background radiations. All of them are not dangerous. Some of them can be dangerous. Now you have to copy this screen. So GM Cube, I have shared a picture with you. GM Cube is basically an apparatus which is like a probe. You can look at this screen and you have to answer a simple question that who is the biggest contributor of background radiation in this data?
Radon gas.
Radon gas, very good. So background radiation wise, the radon gas is the biggest contributor of background radiations. Now, normally background radiation is always there. It's in every room, in every building, but normally it's harmless because it is spread over in a large volume. So normally it's not very dangerous until the count rate is very high. Then it can be a problem. Otherwise, it's a safe. Normally, they are not very dangerous. So I have to copy this screen.
Done.
Now, important individual particles in nuclear reactions. Nuclear reactions mean the reactions in which nuclei are involved. Just like in chemistry, reactions involve electrons. In chemistry, reactions involve electrons, but in physics, reactions involve nucleus. So there are some particles which take part in these reactions. You have to now copy this screen.
Done.
These are the particles, alpha, beta. What you have to learn from here, you have to learn their symbols, like proton has a symbol in physics, positron has a symbol, gamma has a symbol. So these all particles have a symbol. You have to copy this list.
What is below proton?
Sorry,
What is below proton?
proton is positron. It's a particle. You have to just remember the name.
Is the plus one with the positron?
Positron is a positive particle. It is like an electron, but it has a positive charge.
Done.
Now, give a new heading, radioactive decay.
Done.
Now, we have to make a concept here, but I will need some chemistry here. You will be having to recall some chemistry, and in chemistry, when you write an element, suppose carbon 12, 6. 6 is the atomic number. When you write nitrogen 7, 14, 7 is the atomic number. Oxygen 8, and it will be 16. Now, if I write an element X, okay, and I say it is 7 and it is 12. So can you tell me from chemistry that which element is this? You can look here.
Yes.
Which element is this? X.
Carbon.
Hmm?
Carbon.
But do you know that in chemistry, which number is the main number? Atomic number is the main number, or mass number is the main number? When you write an element,
Number.
that this is the, remember, this is the mass number and this is the atomic number. So can you tell me what is the identity of an element? Atomic number or mass number?
Atomic.
Atomic number. Very good. So make this concept clearly. The identity of an element, the identity of an element is the atomic number. So can you tell me again, who is X? X is carbon or nitrogen? Please tell. This is number is 7.
I said nitrogen.
Good. Why it is nitrogen even though that 12 is matching with carbon?
Because the atomic number is 7, and that's what we're
Very
looking
good.
for.
An atomic number is the identity. So it means it is an isotope of nitrogen. It is an isotope of nitrogen. So it is nitrogen. So we have a concept. Atomic number is the identity. Atomic number is the identity of an element. If the atomic number changes, if the atomic number changes, the identity of the element also changes. And this is called radioactive decay. I repeat the concept. When a nucleus emits alpha beta particles, its atomic number Z changes. Its atomic number changes, which means the identity changes. This process is called radioactive decay. So what is radioactive decay? Radioactive decay is a process in which an element emits alpha or beta and its Z atomic number changes. Due to change in atomic number, its identity changes, and this is called radioactive decay. This is now the concept. Now you have to write the first concept here. Identity of an element is its atomic number, Z. For example, carbon 6, carbon 14, 6, nitrogen 7. Atomic number is the identity of an element. Oxygen 16, 8. Oxygen 18, 8. You have to copy this screen. Now we mention our concept that what happens when you have an unstable nucleus. Unstable nucleus, it emits alpha or beta particle and its atomic number, you have to write with me, and its atomic number changes. Which means element changes, and this process is called radioactive decay. You have to copy this. Now, look at the definition. Decay or disintegration is a process in which unstable nucleus emits alpha or beta particle, resulting in a change in its atomic number. Remember, atomic number change means change of element. You have to copy this definition. I'm just coming, copy this definition. This is called radioactive decay. The element you put in the start is called the parent element, and the element formed after decay is called daughter element. You have to copy this.
Right.
There are two types of decays in our course. One is called alpha decay and second is called beta decay.
Right.
Remember that alpha decay and beta decay. So gamma rays do not cause decay. So there are two types of decay. Alpha particles can cause a decay, beta particles can cause a decay, but gamma rays do not cause decay. You have to copy this also.
Done.
Now, I'm starting with alpha decay. Remember that alpha particle is a packet of 2 proton and 2 neutron. So when an alpha particle is released, the atomic number decreases by 2 and the mass number decreases by 4. Atomic number decreases by 2 and the mass number decreases by 4. This is an equation. This is a template to remember. You can look here. Mass number is decreasing by 4 and atomic number is decreasing by 2. This is called alpha particle. This is called alpha particle decay. You have to copy this.
Done. Done.
Now look at this equation. This is a sample set of equations. Fluorine 19,9. Fluorine 19,9 is a sample here. But again, they are not, you're supposed to remember the name of elements, fluorine, chlorine. You just have to understand the letters. You just have to remember the letter number, sorry. 19 becomes 15 as a formula, A minus 4. And Z9 becomes 7. This is called the atomic, this is called the template equation.
But for the alpha, we use it's like helium is the symbol. Then why are we having fluorine on
For alpha, the symbol is He42. For alpha, the symbol is He42. Okay. Now you have to copy these two examples. You have to copy this
But
bracket on.
then why there is fluorine?
No, fluorine is a chemistry. You take chemistry, right? Fluorine
Yes.
is element.
But
Fluorine is an element which decays into nitrogen, and alpha particle is released from fluorine. Fluorine is an element in chemistry. Magnesium is an element. Magnesium decays and it releases an alpha particle.
done.
So we stop here and we will continue in our next class, inshallah. Thank you. Allah Hafiz.